Welcome everybody. Going to be talking today about our project at QUT called Project 85, from digital design to human robot collaborative HRC masonry construction, which is in collaboration with Brickworks and the building for CRC. So before I get into that, I'll just give you a bit of a background on me. Glenda touched on some points there. So I recently completed a PhD at QUT with Glenda as my principal supervisor and Müge as an associate and Marcus Rittenbrook. I'm at the moment, I'm doing a postdoctoral research fellowship with QUT, working on this building for CRC project, and also part of the construction and architectural robotics lab, or CARL, and also associate investigator at the Cobotics Center and a product and user experience designer at Griffith University. So those images there display a little bit about my background. I've actually been around 2 decades in industry, working with advanced manufacturers and custom manufacturers across industrial design primarily, and then moving into more architectural sort of background. And my research was really based around using augmented reality to help companies to produce complex, bespoke products and architectural forms in a more efficient manner. And since then, I've been looking at more. I'm really about how do we get companies, whether in construction or manufacturing, how do we actually get them to adopt emerging technologies in a very human-centered way? So I'm quite passionate about that, bringing that research element, but also the industry element together and combining those together and really seeing how we can move things forward. So that's what I'm very passionate about, and using design as the lens to facilitate that. So a bit about the where this project sits. It sits in the building for CRC integrated. It's an integrated research program, and there's many programs within that. We're number 85, as you can see, so there's a fair few. And now the building for CRC is really about looking at new industry-wide culture, delivering new practices and protocols, developing more sustainable design and construction practices, and new building processes and techniques, leveraging the latest technologies, like we're using collaborative robots, or cobots as they're called. So we're really looking at, how can we bring those technologies and adopt them in a meaningful manner. The building for CRC is a part of, has got a very big amount of partners, commercial and peak industry partners, research organizations, and also project partners. I won't go through all of them there, but you can see on the image there is, a lot of important and people that are doing a lot of great work in the building sector. So for this particular project, number 85, we are project partners at QUT and Brickworks, and Brickworks has been really great helping us with this project. And we've also been collaborating with the Advanced Robotics for Manufacturing Hub, or the ARM Hub, where I actually worked for the past 5 years before I moved to QUT. And then we're also working with Armstrong Bricklaying, who are doing a great job helping us, and Robotics Australia. So just before I go, I'll just talk a little bit about CARL, just to give you a bit of a context. So that's the Construction and Architecture Robotics Lab at QUT, led by Associate Professor Müge Fialho Teixeira and Professor Tim Rose and Associate Professor Carol Hon. And it's really about the vision is to deliver evidence-based research on the use of human-centered robotics in regenerative architectural design and resilient construction methods for a net zero future. And that's really the nexus is, CARL comes within those 3 spheres there. You see the novel material systems, which is where I kind of practice most. And then you've got the health and safety, and then your technology adoption. So those 3 areas are the real key of that. And this project is a key, this project I'm talking about today, the Bricklaying project, is a key project of CARL. So that's just to give you a bit of a background context. And now I'll talk a bit more about the project. So our team for this Bricklaying project is actually a fairly diverse, large team of interdisciplinary designers and architects. So I won't go through everyone here, but they're a fantastic team to work with. And we've also got our industry partners, Lloyd and Maha, who are part of the team, which is really great to be working alongside them and getting their valuable insights. So, study context. So why are we doing this project? So, as everyone probably knows, there's a bit of a housing crisis happening in Australia at the moment, and many parts of the world. And the way things are going, we're not going to meet Australian government targets for the amount of houses that we need, right? And the construction sector has also had a very low productivity rate. It's only moved by up 1% over 2 decades, which is not great. And bricklaying itself has the most significant structural skill gaps in the construction sector, which is not great. We're focusing on brick veneer, which is the most used wall system, but it's also been in decline from 2016 to now. It's gone down around 15. What is it? About 15%. And also, there's low technology adoption. I come from a manufacturing background where technology is integrated very, it's been integrated for a very long time now, since the 50s and 60s. And so I don't see the same happening in construction just because it is not as easy. There's a lot more factors. Automation hasn't worked so far. It has worked in parts, but not totally. And so I think we need, augmented reality and emerging technologies to enhance these sort of human-centered robotic workflows to ensure the bricklaying trade's future prosperity, in my opinion. So I think that's where this project really can shine. So we envisage the future of construction to have people with robots, not just having an automation approach, but where we see actually, humans working alongside robots. So our project, we have several objectives. So we're starting off grounding our research in real world expertise, so through interviews and observational studies of bricklaying. And then from that, we're developing digital design to construction platforms using machine learning and parametric design algorithms. Looking at, like as I was saying, augmented reality, virtual reality, using extended reality to actually facilitate communication and interaction between humans and cobots. And then we're looking at things like optimization of bricklaying. So looking at different things around smarter design, strategic resource management, and also looking at binding solutions. So how can we have more innovative binders that also complement the efficiencies gained in the other aspects of the new design to construction platforms. Our overall outcome for this project, which is a 3-year project, is to produce a lab demo of a brick veneer wall, which is kind of a standard Australian standard wall. And then from that, once we've done that, we're going to look at how can we actually follow up with actually on-site integration testing. To do this, we've got several work packages as well. So, as I said before, we start with the observational studies, then we're actually developing the parametric designed platform, and then we're looking at doing some tests with the actual masons and bricklayers to actually refine it, and then doing some more testing of materials, documenting dissemination, so like writing papers, going to industry conference, talking about getting the word out there, spreading awareness around this topic, which is really important. And then we're looking at some demonstrator projects. So in the next few slides, I'll just go through all the aspects of these projects and talk a bit more about the design methods that we're using and the research methods to actually uncover some insights. I won't go through these too much, but I'll just give you a basic understanding. This is a 3-year project. This was the first year. We've done all these things already so far. We've got a UR16E robot, which we're using. And I'll skip over a little bit. Yeah, this is where we are right now. So we've done a fair bit of work, which I'll show you in a minute. We've got some really cool mobile platforms that we're looking to use. And also next year, the project will finish off with some human robot collaborative tests and some more prototyping of that wall that you saw before. So we began with a bit of that picture's gone a little bit blurry. Sorry about that. But that's the Hadrian X. So we're looking at the state of the art so far. This is where we started to see what's out there already. We've got the material unit lift enhancer, or the mule, which I'll talk a little bit more in the future, where we actually get to use this device, which is really interesting. That's already on site in Australia, being used by companies such as Armstrong Bricklaying, which is really amazing to see. Semi-automatic mason, which is out of America, out of the same company that makes the mule. That's seen some mixed success, but it's a pretty amazing machine itself. Hadrian X out of the Perth company, FBX, is also really interesting, and that's doing some good work. So definitely recommend looking into these a bit more. These are more the industry applications that are out there now being used. In terms of research, there's a lot happening in the space. There's augmented people using augmented reality. There is the cable-driven systems. Monumental Bricklaying robot is a really fascinating one who just received 25 million grant to develop that system, which is amazing. And that's a mobile platform. And then, yeah, there's the Abler system, the Rob unit, which is really interesting, which is actually comes in a shipping container and it's deployed to site and makes sections of walls that way. And then there's the Craftsmac Lab Bristol. There's a few others as well, but these are just some of the key ones that I wanted to point out. It's a fascinating space with a lot of different things, a lot of different applications happening. So, work package one, this is where we began. This was interviews and observational studies of bricklayers. We reached out to, 38 participants. It was really hard to get bricklayers to interview in terms of they're very busy and in demand at the moment, which talks a lot about, that demand gap, demand supply gap. So they're very busy, but it was really useful being able and helpful for having their time to go there and actually have a look at how they do things. And I've got a newfound respect for how hard it is what they do all day long out there in the sun. So it's not an easy job and there's a lot of skill involved. So we tried ourselves a bit of a hand at bricklaying. And yeah, like I said, definitely got a newfound respect for bricklaying. There's a lot involved in bricklaying. I didn't realize how much skill was involved. It's a craft, right? So it's actually very, very you need a lot of experience and practice to get good at it. So there's a lot of things that you can't quantify in getting it right. And it comes with experience. So that was a good exercise for us. We also got to use the Chris Armstrong from Armstrong Bricklaying was kind enough to let us try the mule system. We got to see how it's set up, how it's used. We lifted some concrete masonry units with it. It's quite a fascinating machine where basically that hand gripper that I'm holding there, you press the button to grip the masonry unit and you pick it up. And the thing about that is it's very intelligent in terms of how it judges the weight of the brick and of the concrete masonry unit, and it's actually does a lot of calculations to get the right lift. And so you get used to it pretty quickly. You can pick it up and move the brick without you don't feel any of the weight. And some of those CMUs, they call them, around 27 to 30 kilos, and they're as light as anything. So great for longevity in terms of if you're doing that all day, it takes a lot of pressure off your back and obviously off your muscles, right? So pretty fascinating machine. So from the interviews and the observations, we did actually a thematic analysis. So we've gone in, got all the quotes from all the 7 participants, and we've actually coded these through a process of reflexive thematic analysis of the interview data. And what happens here is we're trying to form what are the overarching themes from all this research, right? So all these, where are the overlaps, where are the discrepancies? And you can see here it's quite a long process where you keep sifting through the data until you kind of develop these themes, right? And from that, we developed 3 key themes. So we found that, enhancing, I probably went a bit too quick, but 3 main themes which inform our paper, which I can talk about in future if you're interested. But our paper is actually in press at the moment with construction innovation, information process management. And the thing about that is, it's a really good, this is a really design research method that we use all the time to document this sort of and get insights from the data. And then from that, we also did the literature review, combine them together, and that's how we form some insights. And that's kind of the grounding for where we go. So we really needed to find out where is going to be the best place, which actually, where do we start, basically, right? So what are the best workflows in human-robot collaboration that we can actually get the most impact, and where's going to be the most useful for the actual bricklayer to be using a cobot. So we divided our observational studies into snippets, and we call these video cards. And what you can see here, the research team were all delegated a number of cards, and we'll actually go through the video and actually define different parameters about it. So, what is the person doing? What are the main what are they struggling with in that task? Would a cobot actually be any help in this task, do you think? Would augmented reality be helpful? Would computer vision, would there be other technologies that would be useful in that situation? And from that exercise, we actually ended up with 6 potential tasks, right? So stacking bricks, shooting mortar, leveling, scanning, passing the bricks, and moving mortar. So from that, that was kind of helping us to get that grounding. We did a body storming workshop in July, which is really a different type of design research method that we use, which is about physically acting out future work scenarios to explore how humans and robots might interact. So it's kind of, I like to call it like a physical brainstorming, right? So you're brainstorming, you're sketching. This is kind of your acting and brainstorming ideas in that way. So there's not, the reason we used it also is because there's not many methods that exist to identify and prioritize human robot collaboration tasks before you actually go and code something and program it. So this is a, kind of an unconventional, but also a quick and low cost approach to get some rich insights and get an understanding of what might be involved. And also, brings that tacit knowledge, embodied knowledge, the sort of things that you're not going to think about if you just sit down with a pen and paper. If you actually act it out, you do get a lot more, insights of things you might not have thought about, which is really exciting to do. So again, these were the 6 tasks that we broke it down into. So during the workshop, we had 6 stations. We had 16 participants, all from different backgrounds. Civil engineering, industrial design myself, HRI, which is human robot interaction, architecture, of course, and a few others, and interaction design. So what we did is we actually made 6 stations that people would actually move around. So we formed, because there was 16, we formed 4 groups, and then it was kind of like a musical chairs. They get like 10 minutes at each station where they have to act and actually act out as if they were a robot. Like there'll be 2 actors, so one's a robot, one's a human, and then there's someone taking notes, and then there's another person who's videoing or taking images or sketching as well, sketching ideas. And that was really fun exercise. And it was about an hour and a half, and a lot of rich insights came out of that. And I think the participants enjoyed it. At first, a lot of participants were probably a little bit, especially those more from the engineering background, might have been a bit like not sure what this is all about. But I think that it was good to get feedback from them that they actually really enjoyed the method, and they got a lot out of it and didn't realize how much types of insights and relevant insights you could get out of this. So that was great. It was really good to hear that from their perspective. And then, so this was really about prioritizing, getting everyone's feedback to help us prioritize which way forward. We also looked at, during that workshop, we also said to consider different complementary technologies like, brain-computer interfaces, augmented reality, what else? We've got tactile feedback, computer vision, humanoids, exoskeletons, and quadrupedals and things like that, and mobile robots. So it's in terms of setting up the task, the body storming workshop, we use simple props, like wooden blocks to replicate bricks, a little, pipes and tubes and whatnot, and also some bricklaying tools like trowels and pointers and things like that. We gave people, sketchbooks and also some prompting material, and some inspirational material just to get them in that zone. And then they would carry out this task. So in this one, they're doing leveling, and we actually use some kinetic sand as a faux mortar. It's a little bit less messy than using some mortar. So we just use that. It's just got a similar consistency in some respects. And it was really fun to see everyone doing that. You can see here someone's doing that, practicing their bricklaying skills with some of that kinetic sand. And it's pretty interesting. And it's kind of there's a bit of play involved in the design, in the thinking, but the outcomes are serious, right? So you do get some good outcomes from that. And you can see also in that form on that page, you can't really see it, but they had a prioritization matrix. So while they're doing this, they're thinking about what they could actually prioritize. So, everyone's getting pretty good at it by now. Once they're getting into that, I was really impressed to see everyone getting really excited and getting stuck into it. So that was good. There was some really interesting sketching and insights coming out of it, which was really, really great to see. Looking at exoskeletons, we've got this future worker who's using an exoskeleton and AR headset. We've got this crawling spider robot that's going up and down the site. We've got also like a mortar fed tube that's attached to and integrated to a robot. So there's some really interesting mobile robots going around a work site carrying bricks around to bricklayers. So from that, we also did some quantitative aspects. So we actually did a Mentimeter poll. So this was after the work, after we did all the actual role play, where we'd actually get everybody to sit down and think about, right, what, from what you've learned today and based on your experiences, what would you think we should prioritize first? And from that, you can see on the right, stacking brick was number one, and then passing bricks to bricklayers was number two. So, and then extruding mortar, and so forth. So that was really good for us to understand, well, where's the priority? What should we focus our development process on next? So yeah, that was great. So we're going to be focusing on stacking bricks, passing the bricks, and extruding mortar. Doesn't mean we're not going to do all of them. I just think it just helps us prioritize if we go off scope a little bit. So to do that for work package 2, we've started looking at, what's the existing, we've mapped out the existing process for bricklaying, and then looking at what does a collaborative robot integrated system process look like, and trying to take out some more steps in that process and just streamline it a little bit more. So, and we're also developing demonstrator projects at this time. This is some wonderful work by our PhD Hamid, who's doing interesting stuff with machine learning and AI, and looking at how to optimize the brick stacking process. So this is great. And this is part of a demonstrator that we've made. This is some of the work I've done. I'm focused a lot more on probably on the augmented reality side of things. So where you can actually, bricklayers can don a headset or glasses and actually see the brick wall where it is, even though it's not physically there yet, and then help them to guide where to put bricks, but also to see if the robot's stacking bricks, they can actually see what the robot's going to do next, if there's any safety issues, and help, maybe they can intervene, through an augmented interface and actually adjust things as they go. So work package 3 is looking about, we started off with just foam blocks originally, then went to timber blocks and bricks, and then we're doing bricks with binders. So these are some we've done with this, some work we've done with timber blocks. We've designed their own gripper, which is also evolving as well. We'll probably do another few iterations of that gripper. I'll sped this up because it's quite a long video, but this is some of the work we've done around the actual bricks themselves. So for work package 4, we actually want to do a robotic automation. So a robot makes a wall, and then we're testing that against a human makes a wall, and then a human with an augmented reality makes a wall, and then a human and robot turn-based system. And we're comparing the pros and cons of each of those and which one's the best way to approach it for a particular task. So you can see there, yeah, that's doing its thing. So we're also looking at binder testing. So we're preparing mortar samples and we're doing compression testing. And also we're going to make some prisms, which is where you get 3 bricks and you put the binder between them. And then we actually test that in a compression as well to see how that stands up. And then looking at how do we actually integrate the mortar system into the actual robot system. So what we found is mortar's a bit tricky to extrude. So we've had to look at an auger system, like you can see here, where I'm using this little device to squeeze it out. It actually works really well in this system, with the aid of some plasticizer. So it flows quite nicely. But mortar is tricky. If you don't have anything else, any other elements, additives added to it, it will not flow at all. So we've done many tests on that, and this is how we found that it actually works. So we want to see how we can integrate that potentially with a robot interfector. Yeah. So that's happening. So we've had some success with publications so far. We've got one in press at the moment. As I was saying before, this is about bricklayers' perspectives on human-robot collaboration in on-site masonry construction. So really defining opportunities, the challenges and the considerations, and understanding, how can we design these systems that are going to be relevant to the bricklayer and then actually benefit them, right? And then BrickNet, which is a computational design framework for robot dataset creation, robust data set creation for robotic fabrication and design automation, which is really interesting. And we have a few more papers in the pipeline around bodystorming, which I spoke about before, and then human robot collaboration in masonry construction. So apart from that, we're very interested in working with industry, especially my industry background. I'm always keen to work with industry. So we do a lot of industry engagement events. This was us at the Building 4 CRC engagement event last year, where Müge went along, and also Lloyd from Brickworks. And they, had the Mule system, and they're trying out a few different things. And it's really great working with Brickworks, who are a really active partner. It's really helpful for us to be working with them because they're always generous with their time, they're passionate, and actually really helping us a lot. It's really been great to see that academic industry overlap work really well. So it's really great to be part of this project in that respect. This is just some more industry engagement with students from a student event, and this was at the Arm Hub. This was actually a industry and student event where students got to have a bit of inspiration on the technology that's coming through in the pipeline, and bricklaying might look a bit different in the future. And yeah, also the Queensland Major Contractors Association, we went along to that, which was great. We really appreciate them having us there, where we did some demos of the headset and got to learn about all the latest things that happen, fascinating things happening in the construction industry in Queensland. Some of our team have gone to Cadria again, which is a conference was in Tokyo this time. And then, the Canadian Masonry Symposium. And next year we've got a few lined up where we're going to go to HRI in Scotland, which should be interesting. And we've also Glenda's went to McNabb just recently and brought one of the QUT humanoids along, which was quite interesting. Always a great conversation have it around humanoids, right? So that was really interesting and great to do. And that's probably enough from me for now. So keen to hear your thoughts and how we can work together. Thank you very much.
Fantastic, Anthony. Really enjoyed hearing your side of things. I mean, it's been great. So thank you so much. Does anybody from our audience have any questions for Anthony? Let's see. I'll just check the chat as well. Okay, while people might be thinking of a question, I have a question for you. So based on how far we've come on the project, what so far has been most surprising to you in terms of the outcome so far?
Good question. Most surprising? I'd probably say surprising. I'd probably say that just the level of the bricklayers, how much they're actually really excited about the technology. I would say a lot of them, the ones that I've spoken to, are very excited about the technology and look forward to using some of that technology. Not to say surprising in a bad way. I'm sure they're open to technology, but I wasn't sure how they would react. And I've seen very positive outcomes from that. I think they're like, that would be very helpful. Let's do it. So that's been great.
Which is a really good point, because oftentimes in manufacturing and construction similarly, there is I think the perception that people are wary or afraid that introducing robots might take their jobs and things like that.
Exactly, and it's fair enough, right? And so I think there's always that having that conversation and just being straightforward that we're not there to replace their jobs. It's actually to help their jobs in that respect, So and of course, collaborative robots not going to be perfect for every situation. Just the amount of complexity involved in bricklaying. I think that was surprising. That's actually another thing that surprised me, was actually how hard bricklaying is. It's very hard. I just never really thought about it because I haven't moved in that sphere before. But it's actually very hard to get the mortar right. It's a craft to get the mortar right, to get it on the brick right. It's not quite as easy as you think. So,
no, it's not as simple as just having a robot place a brick. Right.
No, because there's so many, the site is so complex as well. So it's, it's typically, in manufacturing, I'm used to more of a, in a factory, things are kind of set out. It's pretty clean. It's, you know, everything's in order. Whereas and you can have some time to refine things. Whereas on a site, everything is kind of all over the place. You've got wires here, you've got water, you know, mud, you've got bits and pieces everywhere. Daylight, you've got people walking through, you've got different trades. There's a lot of sequencing that happens. So there's a lot going on a work site. You know, power, have you got access to power? Have you got things like that, right? Wi-Fi, things like that. It can be hard on the site.
Yeah, quite complex for sure.
It is, yeah.
Yeah, so that I think will be an ongoing challenge moving from, you know, testing how we have, I guess, the robot placing bricks in a more sort of controlled environment and taking that to a construction site, which is where we hope to get to, right? But
that's why I'm in it, yeah, because I really want to see it, you know, translate into. I'm very passionate about translating it into the actual real world outcome. So I want to see. Yeah, but I think you do need to start in the lab just to get rid of. If you started on the site, I think it'd be too hard. So I think if you start in the lab, it's better.
Yeah.
We'll get there.
Yes, we're on our way. On our way. Yes.